if you have the cosine of negative x, we're not even going to try to work that. That equals the cosine of a positive x. So you can just change cosine of negative x to just cosine of what? Positive x. Just eliminate the whole problem if you have a negative right there. Now, for sine negative x, it equals the negative of the sine of the positive x. Okay? No, you are not factoring that negative sign to the front. You are not factoring that negative sign to the front. It's just, this is the trig identity. Now, if you look here, if you were trying to factor that negative to the front, there'd be a negative there, and there's not, is there? Okay? So these are two rules for dealing with the sine of a negative or the cosine of a negative. Now, here's the catch on it. I'm going to show you a little bit about why it works. I ought to put theta there. But if you look at the unit circle, the positive theta is that direction, and the negative theta is this direction. Is that okay? If you look at the x, y values here, remember cosine is the x value, right? Do you notice that it's the value you get here and the value you get here are the same? Notice if you're talking about the y value, up here you're getting a positive y value, but down here you're getting what kind of y value? A negative. So if you're going in the negative direction, you're going to get the same thing you would get going in the positive direction if you multiply it by what? Negative 1. For cosine of negative x, if you're going in the positive direction, that way, or if you're going in the negative direction, you're going to get the same value. And it's true even if you go all the way back here. If you go all the way back here, the cosine value here and the cosine value here are the same. The sine values aren't the same. One of them is positive and one of them is what? Negative. Is that all right? So that's the reason those two rules work, is because you look at the circle. Notice everything that you learn about in trig comes back to this circle. All right. Now, also, while I'm up here chatting for a second, Friday, I will not be here Friday morning early. If you know, they got the thing on campus now, if you're failing class, they want you up here on Friday getting help. Well, you know, hey, I got kids that aren't failing the class, but they're trying to do some pretty advanced stuff, need some help. You come up between 10 and 2, I can help you right here. If I'm not here, I'm in the hydroponics room. Or you can send me questions, inbox me. You know, Mr. Evans, I still can't work 7.4, number 9, and I'll send you some notes about it. Fair enough? But I won't be here early in the first beginning of the day. But Friday from 10 to 2, if you need some math help. If you want to take pictures of these later, go right ahead. But like I say, I took pictures and put them in Canvas. All right, I want you to look at 6.3 and pick a problem that you're having trouble with. Okay? A problem that you're having trouble with other than 21 or 35, because I worked those earlier today and I've already recorded those. But I will work 2 problems from 6.3 that you're having trouble with. Anyone? Something that you're having trouble with, 6.3. You sure? If you're okay with that, I'll flip to the 7.4 Sisson book. So 6.3, we're pretty good. Okay, does anybody have a question from Sisson 7.4? I'll get his, I got hit on the video over here. Anyone 7.4, you need some help? One of them you can't work? We're ready to take the test, Mr. Evans. Anything from 7.4 you need help with? Something you tried to work and you haven't been able to work?
Did you do 7?
On 7.4? 7.4, number 7. Sisson, 7.4, number 7. Yes, ma'am. See? All right. -1, and they got the negative sign there. I'm going to put that negative sign in the numerator so I don't lose it. Square root of 48 sine x equals 1/8. All right. It's a fraction equals a fraction. Multiply both sides by the common denominator of the two fractions. Or, somebody says, you know, Mr. Sturgis, if you take the reciprocal of this one and the reciprocal of this one, they're still going to be equal, right? And notice they both be over a 1.
We already did it.
Ma'am?
We already did it.
We did?
Yeah.
Oh, because you eventually get what? Negative square root of 48 sine x equals 8, right? And what was my complaint about this problem? Square root of 48, right? That should be what? What should that be? That's 16 times 3, so that should be what? -4 square root of 3 sine x equals 8. So then sine x is equal to negative square root of 3 over 2. All right? And there's your problem. You've got to recognize that 48 is going to reduce. I don't even like the fact that I have to write the 48 up there. First thing I want to do is make that what? 4 square roots of 3. Yeah, so yeah, very good. Yes, ma'am. So that, we've seen that one. But is it okay if I just, well, go ahead and tell me what the answers are. I want to say one of them is 4/3 pi, and the other one's what? 5/3 pi? And if I wasn't sure, what could I do? I could go over here and look at my unit circle. 4/3 pi, 5/3 pi. Yeah, I like that. Anything else from 7.4? Since we've already seen that one once, it won't hurt to see it again. Anyone?
Do 19.
19. 19. 7.4, number 19. Okay. Go ahead and multiply both sides by the square root of 3. That way, I can get cotangent 2x equals negative square root of 3. And my problem is I hate doing cotangent because, you know, it's not on my circle, right? What I'm going to do is I'm going to make that the tangent of 2x, take the reciprocal, and then I'm going to take the reciprocal there. Because if it's cotangent, I take the reciprocal, it makes it tangent, take the reciprocal. And then why am I excited about that? Because now I can start looking on my unit circle. But I also have another little thing I got to think about. That's not just plain x, is it? So I will make theta equal 2x. Yes, sir, the man that I always think just sleeps through my class and plays video games is answering it right.
Most of them.
Yeah. Okay, once you get here, you make sure and you list that these are thetas, not x's. And it says tangent of theta would be negative 1 over square root of 3. I look over on my circle, and I find one of them is 5/6 pi. I find the other one is 11/6 pi. But I also know that since there is a 2 there, I have to go around the circle how many times? Twice. So I add 2 pi to that, and that's 17/6 pi. And I add 2 pi to that, which is 20/3 6 pi. Because 2 pi, okay, I'm going to write a little note here. I've added 2 pi, which equals 12/6 pi. So you added 2 pi, which equals what? 12/6 pi. And I went around the circle twice because there's a 2. Then I get all excited because now I'm going to figure out what x equals. And if theta equals 2x, then x equals what? Theta over 2. So x will equal 5/12, 11/12 pi, 17/12 pi, and 23/12 pi. And I like that. I like that. Tell me if you're okay with that. If you're not, let me know, because I want to add a little bit of information to this. But that's what, that's to get me through the test. But I'm going to add a little bit of thought to that. If you don't write this down, you're kind of setting yourself up to make a mistake. If you don't write this down, then you don't get this right. You don't know to go around the circle twice. I know a lot of people get to right here and just do it all in their head. They make a list up there in their head, and they take half of it. I don't like that. I'm not going to know if you got the right solutions because I'm giving partial credit. All right, here's what I want to show you if you just wanted to know. If you look at 5/12, and you added 2 pi to get there, right? Okay. If you tried to add here, you'd add 6/12, right? And then you could add 6/12, 6/12. It looks like you could just put x equals 5/12 pi plus pi over 2 times an n. And where n's always a whole number. And let me show you why. If you put a 0 there, you just get what? 5/12 pi. If you put a 1 there, you're going to get 5/12 plus 6/12, which is what? 11/12. If you put a 2 there, you're going to get 5/12 plus pi, which is 12/12. There's your 17/12. I tried to do a fraction in my head, probably shouldn't have. And then if you put a -1 in here, you would actually go around and you could go to infinity. This is not what I'm going to require you to do, but this is the answer, all the answers. This is the answers from negative infinity to positive infinity. All right? It's going around the circle forever and ever. It gives the idea of repetition. I just want the answers from 0 to 2 pi, so I'm happy with that. Somebody in one of the classes said, can we go ahead and learn how to do this and write that? I won't complain. I mean, you got more than I need. I'm happy. But I wouldn't make a mistake if I did that, because I'll mark it wrong. But that's what I'm worried about, just 0 to 2 pi. Okay? If I can get 0 to 2 pi right, I can probably get you through the next level next year, for those that are going to be studying in my class. Okay, 7.4, 7, and 19. Somebody says he's, well, that's it.